Let's discuss question number 1. By using the formula NCR is equal to n factorial divided by n minus r factorial over r factorial. Show that NCR equal to NC n minus r. First of all, let's start from right hand side. NC n minus r is equal to n factorial over n minus, now our r is n minus r. See that? So if NCR, we will minus n minus r and r factorial. But now we are having r which is not r, is n minus r. So we will follow the formula NCR, it becomes NCn minus r, so is equal to n factorial over n minus r in the bracket factorial times with the n minus r factorial. So if we expand n minus n, right, the n cancel out. Negative and negative r become positive r. So we are getting back the same formula, which is n factorial over r factorial over n minus r factorial. So it's the same like NCR, right? So we can say that NC n minus r is equal to NC n minus r, right? So let's proceed to question number 2. A committee of 5 shall be elected out of 5 men and 3 women. Find the number of committees that can be formed if there is no condition. When there is no condition, we just choose from total. We have 5 men and 3 women. So we have actually 5 plus 3, which is the n. So the n will be 5 men and 3 women. So 5 plus 3 is 8. So out of total 8 persons, we are going to choose the committee. And the committees consist of 5. So it will be r equal to 5. So 8 is the n, r is the 5. So we will use the formula of NCR, which is 8 is the n, c, r is the 5. So that means is 8 choose 5 so that to form a committee of 5 members. So the number of ways is 8 factorial over 5 factorial over 8 minus 5 factorial. So the answer is 56 ways. That is for no condition. For combination with condition, B, it contains 3 men and 2 women. So we need to do the condition by selecting 3 men first, followed by we will choose 2 women. Now we have the total 5 men, so we choose 3 men first. The first condition is 3 men, followed by out of 3 women, we are going to choose 2 women, so it will be 3C2. So the number of ways always follow the multiplication rule, which is, okay, we just multiply 5C3 times with the 3C2. So the total number of ways that we choose a committee contains of 3 men and 2 women are actually using 5C3, 5 factorial over 3 factorial times with the 5 minus 2 factorial times with the 3 factorial over 2 factorial times with the 3 minus 2 factorial. So the answer is, right, so the answer is 30 So we need to show the proper step how to get 30 is the answer for question B. Now next, if it contains not more than one woman, so not more than one woman, it can be 0 woman or 1 woman. Not more than, so it means 0 is considered. So we have to have case 1 and case 2. For case 1, if let's say 0 women. If 0 women, how many men we need? So we have to consider the committee whereby we have 0 women and we should have 5 men to form the committee with all the men. Right, the committee have 5 persons with 0 women. So that means all the men are actually in that committee. So it's 3C0 times 5C5. So we have the answer for that case 1. And for case 2, we consider select 1 woman. And of course from the 3 women, we will choose 1 woman. And then because a committee need to have 5 members, so we need another 4 members, must be 4 men. So we will choose 4 men from the 5 men. So we will say we use a combination 5C4. So the number of ways to form the committee with 1 woman will be 3C1 multiplied by 5C4. So we have 2 possible combinations. So we have to plus the 2 possible. So it's either case 1 or case 2. So because of the or, so we have to plus. So the total number of ways to form the committee is 16 if we follow the condition whereby it contains not more than 1 woman. So the answer is 16. Let's proceed to question number 3. Question number 3. A team of 5 members will be selected for an expedition for an island from a group of 4 swimmers and 3 non-swimmers. Find the number of ways in which the team can be formed if swimmers must be more than non-swimmers. Swimmers must be more than non-swimmers. So we have 4 swimmers and 3 non-swimmers. So a team of 5 members is a condition. We must have 5 members and then the swimmers must be more than non-swimmers. So we have many cases. Let's see case 1. Let's say we have selected 3 swimmers from, we have 4 swimmers, right? So we can say is 4 choose 3, 4C3. And then we need to select another 2 non-swimmers. Why? Because the team must have 5 members. So non-swimmers, we have 3, right? 3 non-swimmers. So out of 3, we need to choose 2. 3C2. So that means the first case, we have 4C3 multiplied by 3C2. This is first combination that we think is possible. We have 3 swimmers, which is more than 2 non-swimmers. For case 2, we select 4 swimmers from all the 4 swimmers, right? So we have all the swimmers. 4 swimmers, we choose all of them. So it will be 4C4, all right? After we choose all the 4 swimmers, we can actually choose 1 non-swimmers because we need to make sure the team got 5 swimmers. So 4, okay, out of 4C4 times with the 3C1. That is another possible combination that we can form, whereby the swimmers is more than non-swimmers. All right. So I don't think we can choose 5 swimmers and 0 non-swimmers because the most is only 4. So we can just add up 4C3 times 3C2 plus 4C4 times with the 3C1. So the answer for question number 3 is 15, 15 ways. Let's proceed to question number 4. Question number 4, a mathematics test consists of 10 questions where 4 of them are questions from trigonometry and 6 are questions from algebra. Candidates are required to answer only 8 questions. Find the number of ways in which a candidate can answer the question if the answer at least 4 questions from algebra. Case 1, 8 questions. Candidates are required to answer only 8 questions. So answer 4 questions from, we have 4 of them are from trigo and 6 are from algebra. So if the student answer at least 4 questions algebra, so answer 4 questions from algebra, so it's actually 6C4. Answer 4 questions from trigonometry. Trigonometry, we have 4 questions. So we can use 6C4, right? We can use 6C4 multiplied by 4C4. So the number of ways is 6C4 times 4C4. So the number of ways is, we will calculate later. For case 2, because of at least 4, so we can answer 5 questions from algebra, right? Because algebra got 6 questions. So if answer 5 questions from algebra, that means for trigonometry, he need to answer 3 questions from trigonometry. And he also can answer so 65 times 4C3, right? So we have different combination for case 1 and case 2, and we have case 3. So we also have case 3 whereby we can choose 6 questions, right, from the algebra. That means all are algebra, and 2 questions from trigonometry. So we have 6C6 times with the 4C2, right? So this is also another possibility whereby fulfill the condition at least 4 questions from algebra. It means it can be 4, 5, or 6 questions of algebra with the balance will be the trigonometric question, and the quantity of the question must be 8. So all the answer you need to plus from case 1 to case 2 and case 3, you have to plus the answer, and the total answer is equivalent to 45 ways. So we can say that the answer is 6C4 times 4C4 plus 6C5 times 4C3 plus 6C6 times 4C2 equal to 45 ways. That is the answer for this question. Let's proceed to the next question. A delegation to Malacca consisting of 12 people has been planned. Find the number of ways to provide transport for these 12 passengers. If A, 3 cars are used, and each car can accommodate 4 people. So, let's see. We are going to uh, send 12 people to Malacca. The delegation consists of 12 people, and then each car can accommodate 4 people. So, in order to select, we need to select the 4 people from 12 people first to make sure they are go to the first car, 12C4. After that, for 8 people remains, we will choose another 4 for second car. So it will be 8C4, right? And finally, the balance is 4. So for the second car, we can say that we actually chose 4 out of 8. And for the third car, the balance of 4 people will go to the third car. 4 people remains, so be 4C4, right? So the number of ways to arrange a third car will be 4C4, right? Select 4 people for the third car will be 4C4, right? So because we are selecting one followed by another one, so we have to multiply 12C4 followed by times with the 8C4 followed by multiply by 4C4. So the number of ways is 34,650 ways for question A. Let's see how to solve question B. For B, 2 vans are used and each van can accommodate 6 people. Alright, now we are changing the car to van. So out of 12C6 times 6C6, because of the balance of the 6 will go to the second van that can accommodate 6 people. So the number of ways if 2 vans are used and each van can accommodate 6 people will be 12C6 multiplied by 6C6. So the total number of ways is equal to 924 ways. Let's see how to write the steps for choosing 2 vans to use, and each van can accommodate 6 people. So the final answer will be 12C6 multiplied by 6C6. So equivalent to 924 ways. So that's all my sharing for today's combination with condition. Till then, bye bye and have a nice day.